So the first talk is SparqlExplorer, Exploring Linked Open Data by Elodie Thieblin. Elodie did a PhD on complex ontology matching and afterwards started working for Logilab, where she develops web applications often in the scope of linked open data. So, Elodie, you're welcome to start your presentation.
Thank you, Ulysse. So I'm here to present, as Ulysse said, SparqlExplorer. Before I present to you the tool, let me show you why we created this tool. We often have, we often need people who have put in the efforts to create, they had data, but it was poorly expressed and so on. So they've put in the effort to translate it into RDF, to use the W3C standards. And then they've put it onto a SparqL endpoint and they're like, here, internet, here are my W3C standards data. But on the other side, on the other hand, we have users and they can't read RDF and they can't write SparqL queries. So they're like, oh, your data looks great, but I cannot use it, I cannot see it, I don't know what to do with it. That's why we created SparqlExplorer. We wanted to make it possible that an end user could navigate a SparqL endpoint like they would navigate on the web. So to do so, we have defined very simple basic behavior. The first thing is a homepage with basic text search and a list of the classes of the SparqL endpoint. And then in the SparqlExplorer, you can navigate URL by URL on the data of your on the data that is available on your SparqL endpoint. And we have a very classical display that I will show now. So this is SparqL endpoint. This is SparqlExplorer. Sorry. So I will do my demonstration on data IDRF, which is a SparqL endpoint containing bibliographic data of French research, basically. So it's not an endpoint that we created, that's something that's already there on the web. So here, this is the main page of the SparqlExplorer. We have a search bar where you can search text. And you have a list, the list of classes which are available on this SparqL endpoint with a number of instances. The search bar uses a very simple SparqL query, which is basically give me all the triples where my object is a literal and this literal looks like what you've just typed. The problem is on very wide, very large SparqL endpoints, you cannot get a result quickly. That's why I will not demonstrate it there. But if you have a small SparqL endpoint, it works fine. Then on the list of classes, you can, these are URLs, so you can visualize them. And this is the default view. So we are currently visualizing the biobirth URL, and we have the list of triples in which it's there. And if there's a graph, in which graph this triple is shown. Then you can search the triples. For example, I'm looking for type triples, and I'm looking for, I clicked on this URL, so now I'm visualizing this URL, and so on. So that's it for the basic behavior. Now we're like, well, this basic display is not very friendly enough. The difference between dealing with RDF triples and this tabular view is not very, well, there's not much difference. So we wanted to propose a tool that would provide visualization based on the data relative to a URL. We wanted to say, okay, this URL is about a person, so is there some kind of view, some kind of visualization method that can display the data relative to a person? How can we do that? That's why we proposed a view server. In a view server, we have a list of views, and we've defined this simple API. So a view is a script, and in this script takes as input the URL of a resource and the SPARQL endpoint URL where this resource is described. This view can do data retrieval on the SPARQL endpoint if need be, and we have defined this API that's very simple. There are two functions on the view. Is this view applicable to this URL on this SPARQL endpoint? And please render this URL, the data relative to this URL on this SPARQL endpoint using whatever library you want. And it will, and the render function will generate HTML. So then we are like, okay, so we have a list of views. We've put all of our scripts in the view server. And now we want the SparqlExplorer Explorer to select a view. We've given it the SparqL endpoint. We've given it the view server. It knows where what URL we are depicting. So it has to choose which view it wants to use. So this is how it works. Up. So we are visualizing. I'm not going to succeed saying that. So we want to see this URL on this SparqL endpoint using this view server. SparqL endpoint sends a request to the view server where we have a list of views that's ordered. So the order of the view is important. The first one, if it's applicable, will be selected. If not, it will go to the second one, etc. So the SparqL endpoint asks the first view, are you applicable to my URL and on this SparqL endpoint? The view will retrieve data from the SparqL endpoint. For example, it will, if the first view is a view about displaying person or people information, it will ask, is URN 123 a fourth person? And the SparqL endpoint will answer. And based on this answer, view number 1 will say, I'm okay or I'm not. In this case, the first view was not applicable. So the SparqL endpoint goes to the second view, are you applicable? And so on. So the second view will ask, for example, if it's about book displaying, is URN 123 a book, for example? Does it have a title? Then the SparqL endpoint will answer. And the second view says, okay, I'm applicable. So we're done for view selection. Now we'll go to view rendering. Now that the SparqL Explorer knows that view number 2 on this view server is applicable, it will send the message, now render. So view number 2 will retrieve the necessary data that it needs on the SparqL endpoint. Then it will generate the HTML, send it back to the SparqL Explorer, and the SparqL Explorer will display it. So I will do again this small demonstration. Yep. So here we have the view server. So it's a basic, the view server is a web server on which we have the view script. So here it's JavaScript. And we have the list of views, which is in this file. So you see it's an ordered table. You have a first view, which is for cost concept. We have description of the view, and then we have the link to the view script. That's it about the view server. Yep. So now, if I go back to my SparqL Explorer, I tell him I want to explore this data, so the same SparqL endpoints about research by bibliography in France. And I'm telling him, here is my view server, so that's the URL of this file. Then I click OK. So the homepage view is exactly the same. I have the list of classes, and I have my search bar if my dataset is not too big. Then let's go to a fourth person, whatever. Then I'm looking at the fourth person, And I can go on the three dots, and I have the list of views that are available. So there are two modes in the SparqL Explorer. We have the manual mode when you want to try if is this view applicable. So here I manually selected the view all class, and I have the list of classes. And there's also the automatic mode, which I described just before, which goes to each view and asks, are you applicable, and then renders the results. Up. So if I click on another URL, I have a new view, and if I go there, it tells me, oh, okay, I'm on automatic mode, and I selected the fourth view. Up, I'm going to another URL, and he selected the Dublin core view. We have the title, the list of contributors, and for example, the subject. And if I go to this subject, it's loading. I still have another view, and it's the SCOS concept view. Thank you. So you've seen we have so that was it for the SparqL Explorer. So the pros of this tool is that it's a tool. It's on the web, so it's a web application that is on shelf. I mean, we developed this tool. We developed also the view server, but the SparqL endpoint was developed by someone else. Also, one interesting thing is that you can plug any SparqL endpoint with any SparqL endpoint and any view server. So if you want to develop your own view server using the view server API, the views with the is applicable and the render functions, it will work just fine using the SparqL Explorer. The SparqL Explorer will do the link between the view server and the data on the SparqL endpoint. The other pro of having view servers is that you have on-shelf web interfaces for data producers. If the data producer is a small institution and doesn't have the budget to create their own website based on their SparqL endpoint, or if they don't have data to show, or well, if they don't have, sorry, a website to show their data, they can still point to this tool and have the data clickable, navigable. So the cons of this tool are, as I said, the performance issues, especially on text search on large datasets. We know that there are some possibilities. For example, if you use Jena, you can use Lucene and etc. to index your RDF data. However, we wanted the tool to be as wide as possible. That's why we created the large, the most applicable query for the text search, and that's why it's very heavy. But it's more a query on it's more a cons on the SparqL endpoints in general, that they don't have a text index easily queryable. And also here we just have an example with one view server that we developed on both SCOS and Dublin Core. But if we want this system to be more usable, it would require that view servers are developed on other standards or with other design, for example, on the same vocabularies, and that would be great. So thank you very much for listening to me.